Hi, Assalamualaikum. My name is Muhammad Amirul Isham bin Razian and my matrix number is HE210043.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. My name is Naomi binti Adam and my matrix number is GE220028.
Okay, now firstly I would want to explain how we get the equation to be interpreted to MATLAB. Okay, we are referring to this equation which is A cos 2 pi ft plus minus the phase, and then let's see if you want to take the letter of u. Okay, now we are referring to the table that have been given to us, is this table, and now let's say we want to interpret u. So the magnitude is 2 and also the phase ingredient is 0. So we have that kind of information, so we interpret it as 2 cos 2 pi ft. So the phase is 0, so the equation will be like this. And then the next thing, uh, we want to choose the frequency for this equation. So we are not gonna use the same frequency. That is because uh, the first one is it can cause to the signal may be interfere, and also will the signal will lost. So that's why we don't want to have the same frequency for each equation. So let's say if we increase it by 2, so then up till the next equation, the frequency here will be like 4 pi ft and 6 pi ft, something like that. And then we are choosing the frequency for the sampling from the equation is how okay, we do like, so let's say mutation gemilang have the maximum frequency of 13. So let's say 13. Okay, then we choose the highest frequency, and then we times it by 2, because this is from the equation of P of 2f, 2 times of the frequency, so that we will get a total of 26 that will be used as the sampling frequency. Okay, so now I would want to show you the MATLAB. Okay, so here this is the code for mutation gemilang. So let's say here we are using sampling frequency of 100 because we would want to have a better resolution. So it is either we can use more than 26, so we choose 100. We can also do 50. So here this is the interpret equations from the words mutation gemilang, including the space. And then if we run it, so this is the signal that we have obtained. So at the lowest point of this is 1, and also the maximum is 2, the magnitude. Okay, so this is for the mutation gemilang. Okay, for the second signal, okay, dengan hikmah kita meneroka. Okay, the second signal, the equation is quite long, so this is the equation that have been interpreted to MATLAB. So we are using the same sampling frequency, and then okay, before I forgot, first thing is the code Q2 is equal to FFT Q2. This is to enable us to have a better view of the signal for the sampling for the discrete type. Okay, so let's say if I run this code. Okay, so let's say this is the signal for the second words. The highest we get at 2, the magnitude, and also the lowest is at 1. So okay, let's say whenever this time is I'm using the sampling of 100. So let's say if I change the sampling to, let's say I change it to 50. Okay, the resolution will be much lower than before. So that is why we use 100 sampling. So the coding for Fast Fourier Transform is so that we have a better view like this, discrete form, rather than this type of signal. So this is for the second. Okay, so this is the last words for the question, which is mutation produce professional. Okay, for this we are also using the sampling of 100, and then the equation goes from the frequency of 2 until 52 to avoid interference or the signal being lost. And then we try to run this code. Okay, and we will get this signal this here, the discrete one, that one for the magnitude and phase. Okay, so same like before, the highest, the peak value of the magnitude is 2 and the lowest is 1. And then, let's say if we try to change it to, okay, so before this, I'm trying to lower the sample. So this time I'm trying to increase the sample. Okay, so compared to before, these have a much better resolution than before. And then so if they have a lot more sampling, so the graph will be much smoother, and also it's easy to view.
Okay, I would like to continue the presentation with my part, which is my part is to encode the signal to alphabet. So let's start. So first, I will do the simulation on MATLAB. So we try it on the MATLAB. So this is the coding for our question 1, and which is we use S is equal to 30. S is the sampling, which is 30 is 30 Hz. This is because our signal they're given in the Excel, we have a 0.03. This one. As we can see at here, we get the time as a 0.033. So that's why we could get the sampling is 30. So next is the coding for time sampling, which is 1 over S, and then the N is the number of the signal, which is the 0 until N minus 1. Actually, all of the data, we could get the 600 for the signal 1. That's why 600 minus 1, we could get the 599. So at here, this is we put the signal in the Excel. So, and the signal in the Excel, we just put in our MATLAB as a 1 decimal places. And this one we need to do the Fast Fourier Transform to get the magnitude and phase graph. So next we will run it. So as we can run it, this is our signal. So to encode our alphabet, just like for signal 1, signal 1 is for to encode the alphabet with dash M gemilang. So we need to find at here the phase and the magnitude that available in our table given. So this one is our example. So if I put here as 108, which is 108 is our frequency and Y is our magnitude, and we get 0.9, we can round off as 1. So at graph phase, we need to find also at frequency 108. So as at here, we could see that we get the phase is as a negative 2.5. So 1 and 2, negative 2.5, when we see in the table of alphabet that given, when the magnitude is 1, also for this we could we could not get the alphabet because magnitude 1 and the first negative 2.5 is not available at here. So we try to another value, which is maybe 110, which is also 1, and 110 we have a magnitude 1 and phase 1. So 1, magnitude 1 and phase 1, we could get the at here we maybe can use the alphabet for C and alphabet M. So that's how we encode the signal into the alphabet, and we need to find it at MATLAB for each of UTHM gemilang, which is alphabet UTHM, gemilang is GEMILING. So next I will show you guys how to run the question 2, which is the question 2 for the word is dengan hikmah meneroka. Dengan hikmah kita meneroka. So we run it, and for signal 2 actually we have more data. That's why we could get our data is around 600 to 700. So this is our data. So next is the question 3, which is UTHM produce professional. So at here we could get like this, and as we know, signal 3 we have the most data, which is at around 1000 until 1200. So next we will discuss on result for the 3 signal. So let's dive in. So UTHM gemilang, this is how we encode the alphabet. So we try to find each of the signal that can encode each of the alphabet. So this one we could get. So as we know, the UTHM gemilang is actually we have a UTHM GEMILANG, which is 12 alphabet. So at here you can count, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We get 13 alphabet, but we also have space. So that's how we get we could get the UTHM gemilang with the space, sebab which is space is have a magnitude and phase also. So next is dengan hikmah meneroka. So dengan hikmah kita meneroka, we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25, and 26, and 27. So we need to get 27 value in the output, which is the result. Same also the UTHM produce proportional. So at last that we can summarize for this project. As we finish this project, we could understand more in discrete Fourier transform, and we could generate the signal from the alphabet, and also we could encode the signal into alphabet. So we also know that discrete Fourier transform is very larger, and we can use anything with that. That's all from us. Thank you.